This is chapter number 17. It's about angle and cyclic properties of circles. Now, before we actually go to the properties of circles, there are a few things that you have to know about a circle. This line that you see is called the circumference of a circle. So this is called the circumference. And this point is called the center of the circle. So O is the center of the circle. Now, I'm going to consider 2 points on the circumference of the circle. Say one is point A here on the circumference of the circle, and another point is B. If I join A with O, A is a point on the circumference with O. This straight line is the radius of the circle. So O to A is the radius of the circle. OA is the radius. Similarly, if I join O with B by a straight line, this length OB is also the radius of the circle. So OB is also the radius of this circle. Both should be same. AO and BO. Both are radii. Okay. Both should be of the same length. And if this straight line joining 2 points on the circumference passes through the center, if this is a straight line joining 2 points on the circumference of the circle, and if that straight line passes through the center, then such a straight line is called the diameter. So this and this put together, that is radius, one radius, another radius in a straight line, that is AB as a straight line, is the diameter. So the diameter is actually made of radius and one more radius. So 2 times the radius is the diameter. Okay. Now, if I consider another point on the circumference of the circle, let's see, and one more point D on the circumference of the circle. Okay. Let's forget about AB. We are considering C and D, 2 points on the circumference of the circle. Now when these 2 points are fixed, this whole circumference is divided into 2 parts. One is CD, which is this part, okay, from C to D is this curved part. And the other CD is, it starts from here, it goes all the way around and comes to D till here. That is also part of the circumference. Now these parts of the circumference are called arcs. The smaller one is called a minor arc, and the bigger one, this CD, is called a major arc. Okay. So this is called a minor arc CD, and this is called the major arc CD. So CD can be a minor arc or it can be a major arc. So if the arc is smaller in length, it's called a minor arc. If the arc is bigger in length, then it's called major arc. So this portion is called the minor arc, this portion is called the major arc. Okay. Now, if I join CD by a straight line, that's a straight line. Okay. Joining C and D, 2 points on the circumference. But look at this. These are also 2 points on the circumference joined by a straight line. But this straight line passed through the center. Therefore, this straight line is called the diameter. These are also 2 points on the circumference joined by a straight line. But this line does not pass through the center. Therefore, such lines, such straight lines which join 2 points on the circumference are called chords. Okay. So CD as a straight line is called a chord. So AB is also a chord because it joins 2 points on the circumference, but this chord passes through the center. Therefore, this chord has a special name, that is, it is the diameter. Okay. So about a chord is a straight line which joins 2 points on the circumference. So this is also a chord, but this chord passes through the center. Therefore, this chord is called the diameter. Okay. Now, when this chord is drawn, this whole circle is divided into two parts. Okay, forget about this line. This is the chord. This chord divides this whole circle into two parts. One is the smaller part, which is here. I will just shade it. This is the smaller part. The other part is the unshaded portion, this portion. Okay. Such portions which are between a chord and an arc are called segments. They are called segments. This segment which I have shaded lies between the chord and the minor arc. Therefore, this segment is called a minor segment. Because it lies between the chord and the minor arc. Therefore, this area which is there in between them, which is shaded, is called the minor segment. And between the chord and the major arc CD, this is major arc CD. So this portion, unshaded portion, this is called the major segment. So minor segment lies between the chord and the minor arc, and the major segment lies between the chord and the major arc CD. So all of them are CD. Whether it is a minor arc CD is this CD. Major arc CD is from here to here, that's major arc CD. This is chord. This straight line is also joining C and D, so that's also CD. CD can be a chord, which is a straight line. CD can also be a portion between chord and the minor arc, so CD is a minor segment. CD can also be lying between chord CD and major arc CD, which is this unshaded portion, which is called the major segment. And one other thing that you have to know is, if there is a straight line which comes from infinity and it touches the circle and goes to infinity. Okay. Such straight lines which touch the circle at just one point and goes to infinity. Okay. It does not cut the circle. Such straight lines are called tangents. So this is a tangent. Okay. So there are a few things that you have to know. This line which is curved is called the circumference. O is the center of the circle. OA, this length, is called radius. OB is also the radius. AB, which is a straight line passing through the center, is called diameter. CD, when C and D are fixed on the circumference, this portion of the circumference is called minor arc, and the remaining portion CD is called major arc. CD as a straight line is called a chord, and the portion between the chord and the minor arc is called minor segment. The portion between the chord CD and major arc CD, that's this unshaded portion, is called major segment. And finally, a straight line from infinity which just touches the circle and goes to infinity is called a tangent. Okay. So these are few things that you have to know about circles. Now coming to the properties of circles. Theorem number 1. The angle which an arc of a circle makes at the center is double that it makes on the circumference. I will show it to you in the figure. Let's say A and B are 2 points on the circumference of the circle. This is the circle. I fixed 2 points A and B. Okay. So A and B are 2 points. These are the 2 points. Okay. When these 2 points are fixed, this AB is called an arc. This is arc AB. And this arc AB makes an angle at the center. That is AOB. The angle made is here. This is the angle. Okay. Name of this angle is angle AOB. Now, how do you know which arc makes it? Is the first alphabet and the last alphabet, these two together shows which arc makes it, and the middle alphabet shows where the angle is made. First alphabet, last alphabet is the arc which makes it, and the middle alphabet is where the angle is made. Okay. So first alphabet, last alphabet is A, B. So A, B is the arc, okay. And O is the point where the angle is made. O is here. That's the angle. Okay. Angle A, O, B. Always the middle alphabet shows which is the angle. Okay. So angle is at O. Okay. So this is the angle made by arc AB, and this angle is made at O, where O is the center. So this is the angle made at the center. Okay. Now the same arc AB is also going to make one more angle, but that angle is made on the circumference. The second angle I am going to consider is this one. Name of this angle. It is made at C. So C should be in the middle. It starts from A, C, it ends at B. Okay. So angle is ACB. Again, coming to this angle ACB. The first alphabet and the last alphabet says which is the arc which makes it. So the arc which makes it is AB. Both cases it's the same. Both are made by the same arc. This is AOB, this is ACB. First alphabet, last alphabet are same, which means both are made by the same arc AB. This was made at the center, that's O. Now see where this is made. This is made at C. But where is C? C is on the circumference. So this angle is made on the circumference. First one was made at the center, second one is made on the circumference. According to this theorem, it says the angle which an arc of a circle makes at the center, the angle made at the center, that is this one, is double that it makes on the circumference. This angle made at the center will be double of whatever is made on the circumference. But both these angles should be made by the same arc. So check and see whether both of them are made by the same arc. AB, AB. Both are made by the same arc. But one is made at the center, one is made on the circumference. So the angle made at the center will be double of whatever is made at on the circumference. Which means if this was 30 degrees, that's the angle made on the circumference is 30. Which means angle made at the center must be double of whatever is here. Double of this will be 60 degrees. Or in other words, angle on the circumference will be half of whatever is made at the center. Okay. Angle made at the center is double of what is made on the circumference, or angle made on the circumference, this one, is half of what is made at the center. So that's what I have written here. Angle AOB, that's angle on the center, is double, 2 times. Angle on the circumference, C, is on the circumference. Or angle on the circumference, C, is the angle made on the circumference, is half of whatever is made on the, at the center. Okay. So this is the first theorem. The second one. Angles in the same segment of a circle are equal, or angles made by the same arc are equal. But angles made by the same arc are equal means both the angles should be made on the circumference. Because according to the previous case, if there are two angles made by an arc, if one is at the center, one is on the circumference, angle at the center will always be double of whatever is made on the circumference. Here it says angles in the same segment of a circle are equal, or angles made by the same arc are equal. Let's take this. AB is the arc. First angle made by AB is ACB. This one. Angle ACB. Angle ACB. Arc which makes it is AB. First alphabet, last alphabet. Where is the angle made? At C. C is on the circumference. The other angle made by AB is ADB. Angle ADB. Arc which makes it is AB. Look at both. Both of them are made by the same arc. AB, AB. Both are made by the same arc. First one is made at C. C is on the circumference. Let's see where D is. D is also on the circumference. Both are made by the same arc and both the angles are made on the circumference. Then both these angles should be same. If this was 40 degrees, this also must be 40 degrees. So that's the second property, that is angles in the same segment of a circle are equal. You can also write angles made by the same arc are equal. Okay. So angle ACB, the first one, will be equal to angle ADB, the second one. Both these angles will be equal. Third property. The angle in a semicircle is the right angle. Angle in a semicircle is a right angle. Forget about the lower portion of the circle. Let's take only this. This is a semicircle. Any angle on the circumference here will all be 90 degrees. That is, AB is the arc, this one. This AB makes an angle on the circumference. It can be here, it can be here, it can be here, it can be here, anywhere on the circumference. All these angles will all be right angles, means it should be 90 degrees. So angle in a semicircle is a right angle. How is it 90? Okay, how is it a right angle? Is. Let's consider AB is the arc. Okay, this is the arc. This arc AB makes an angle at the center. The angle made at the center is this one. Name of this angle is angle AOB. Even though it's a straight line, there is an angle. Okay. The angle is AOB. Let's check and see which is the arc which makes it. AB is the arc. This one. Where is it made? At O. Where O is the center. And if this is a straight line, how much is this angle? Angle on a straight line is 180 degrees. So that much is 180 degrees. Let's go to this angle. Name this angle. The angle is ACB. Angle ACB. Which is the arc which makes it? AB. Same arc. AB. But where is this made? At C. C is on the circumference. According to the first theorem or the first property, it said that angle at the center is double angle on the circumference. Angle at the center must be double of whatever is on the circumference, or angle on the circumference will be half of whatever is made at the center. Angle on the circumference must be half of whatever is made at the center. Angle made at the center is 180, which means this must be half of that. Half of 180 is 90 degrees. So this angle is always a right angle. That's why the angle in a semicircle is a right angle. So look at the semicircle now. This is the semicircle. Angle in the semicircle is always 90 degrees. I can draw one angle here. This will also be 90. I can draw one angle here. This also will be 90. Okay. So angle in a semicircle is a right angle, or the angle made is 90 degrees. That's the third property. Before we go to the fourth property, I've drawn four figures here. All four figures are inside a circle, and all of them are quadrilaterals, four-sided figures. A, B, C, D is a quadrilateral, four-sided figure. X, Y, Z, W, a four-sided figure. P, Q, R, S is a four-sided figure. O, A, B, C is also a four-sided figure. All of them are called quadrilaterals. But if a quadrilateral is inside a circle and if all the four vertices of this quadrilateral are on the circumference of the circle, then such quadrilaterals are called cyclic quadrilaterals. Look at this. This is a quadrilateral. It is inside a circle and the four vertices of this quadrilateral, that is A, B, C and D are the four vertices. If these four vertices lie on the circumference of the circle, then such quadrilaterals are called cyclic quadrilaterals. So is A on the circumference? It is. B is also on the circumference. C and D, all of them are on the circumference of the circle. Therefore, such quadrilaterals are called cyclic quadrilaterals. They are called cyclic quadrilaterals. Okay. So ABCD in this case is a cyclic quadrilateral. Let's check whether this is a cyclic quadrilateral. X is on the circumference, Y is on the circumference, Z is on the circumference and W is also on the circumference. Therefore, X, Y, Z, W, this quadrilateral is also called a cyclic quadrilateral. Third figure, P, Q, R, S is the quadrilateral. All four vertices P, Q, R and S, all of them lie on the circumference of the circle. Therefore, this is also called a cyclic quadrilateral. Check the last one. A, B, C and O are the four vertices. A is on the circumference, B is on the circumference, C is on the circumference, but O is not on the circumference. O is the center. Therefore, this is a quadrilateral but not a cyclic quadrilateral. So about a cyclic quadrilateral, you should know it's a four-sided figure. And if all four vertices lie on the circumference of the circle, then such quadrilaterals are called cyclic quadrilaterals. So all these three are cyclic quadrilaterals. This is not cyclic because three vertices are on the circumference, but the fourth vertex is not on the circumference. It is at the center. Therefore, it is not a cyclic quadrilateral. Okay. So that's about a cyclic quadrilateral. So the next property two properties are about cyclic quadrilaterals. Theorem number 4. The opposite angles of a cyclic quadrilateral are supplementary. We'll come to this later. First, let's check the figure which I have drawn has a cyclic quadrilateral or not. About a cyclic quadrilateral, it is a quadrilateral four-sided figure and all the four vertices must lie on the circumference of the circle. A, B, C, D is the quadrilateral. A, B, C and D, all of them lie on the circumference of the circle. Therefore, ABCD is a cyclic quadrilateral. Now coming to this property, it says the opposite angles of a cyclic quadrilateral are supplementary. The word supplementary means they add up to 180 degrees. Supplementary angles means they add up to 180 degrees. Here it says opposite angles of a cyclic quadrilateral. This is the cyclic quadrilateral. Opposite angles of the cyclic quadrilateral. If I consider A is one angle, opposite to this is C. That's the second angle. These two added together should give you 180 degrees. That's why it says it should be supplementary. This and this added together should give you 180 degrees. That is A plus C should give you 180 degrees. Other two opposite angles are that one, D and B are opposite angles. Okay. These two are opposite. Opposite angles of a cyclic quadrilateral are supplementary. Means these also add up to give you 180 degrees. That is B plus D also gives you 180 degrees. A and C added together gives you 180. B and D also added together should give you 180 degrees. So opposite angles of a cyclic quadrilateral are supplementary is the fourth property. And the last property, theorem number 5 is the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Now, first thing is check whether it is a cyclic quadrilateral. ABCD is a quadrilateral. A, B, C and D, all of them lie on the circumference. Therefore, this figure is a cyclic quadrilateral. The property is the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. First, you should know what an exterior angle is. For any figure, how do you get an exterior angle? Is by producing one of the sides of that figure. We are talking about the cyclic quadrilateral. This is the cyclic quadrilateral. You extend one of the sides. The side which I have extended here is DC is the side of the quadrilateral. I have produced that one, extended it to a point X. So by extending one of the sides, the angle that you get outside this, outside the quadrilateral, this angle is called the exterior angle. According to this property, it says the exterior angle, that is this one, is equal to interior opposite angle. So which is the interior opposite angle of the cyclic quadrilateral? Can't be this. This is adjacent. Okay. If this is adjacent, this is also not opposite. This is also not opposite. There is only one opposite angle. Opposite to this is this angle. These two angles will be same. Exterior angle of a cyclic quadrilateral is equal to opposite interior angle. Now, how is it equal? Is according to the previous property, opposite angles of a cyclic quadrilateral are supplementary. Let's take this one is 120. Opposite to A is C, this one. These two added together should give you 180. So if 120 plus 60 will give you the 180. You got this is 60. This is a straight line. If this is a straight line, the sum of angles here is 180. So if this is 60 and this added together is 180. So from 180 take away the 60, you will get this is 120. Now check and see. Exterior angle which is 120 is equal to opposite interior angle which is also 120. So angle BCX, which is the exterior angle, is equal to angle DAB, which is the interior opposite angle.